Last time, we had spent some more time in section 4.1. We had talked about how to find angles not using the unit circle and these inverse functions. Asked you guys to work on what, like 7 through 10, and then worksheet 2. Start with questions. Has anybody got questions?
Sorry, I'm not on this.
Okay.
Number 5 on the worksheet.
5 from the worksheet. Sure. All right, number 5 on the worksheet. First thing we need to do is figure out the quadrant that our terminal side lies in. So that's the same thing as cosine theta equals 0.19. On the unit circle, cosine is the same as which coordinate? X. If you don't remember that, I would put that on my equation sheet. And where is the x coordinate positive? Which quadrants? Over there, right? So that's 1 and 4. Cool there. Okay, I'm going to draw a picture now and figure out what coordinate or quadrants are covered by the angles from 11 pi to 12 pi. So I always start on my positive x-axis. Because these angles, 11 pi and 12 pi, are positive, I rotate counterclockwise. If you didn't remember that, I'd put that on my note card. So half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5 to 12. So we covered quadrants 3 and 4. So where's my answer at? It's in quadrant 4. So draw my initial side and my terminal side. And now I'm going to draw in the rotations for my angle theta, which again is going to take 100 years. Because again, it has to lie between 11 pi and 12 pi. So half, 1, 1.5, 2, 2.5, 3, 4, 5, 6, 7, 8, 9, 10, 11, and there we're at. So this one would have been 12, because over here was 11. And then this spot here is my phi. So I'm going to ask myself, is 12 pi bigger or smaller than my theta? Bigger, right? Because my theta stops before I get to 12 pi. So I know I should be subtracting from 12 pi to get theta, since theta is smaller than 12 pi. And what am I going to subtract? Phi. And how do I calculate phi? I just do the absolute value of whatever I was taking the inverse of in the original problem. And then it's just calculator time. And again, I'm not going to bother with the absolute value part. I'm just going to evaluate the absolute value in my head because all I have to do is make something positive. Oops. That looks like a bonkers answer. What should I have checked before I did this? Yeah, I want to make sure I'm in degree mode. Uh-oh, SpaghettiOs, I wasn't. Try that again. There we go. 36.32 or thereabouts. What should I do to check that? Yeah, I want to make sure that cosine of that angle does give me 0.19. Does. And then I want to make sure that 11 pi is smaller than 36.3. It is. And that 12 pi is bigger. It is. So I am satisfied. Again, all of these ones on like worksheets 1 and 2 are all checkable. You know, like no reason to get any of them wrong. You know what I mean?
Yeah.
I mean, if you can't figure it out, that's one, you know, if you make a mistake, but you should know that it's not right when you quit. You may not be able to get it right, but you should know that whether your answer is right or wrong, kind of. You know what I mean? At minimum that. Ideally, you'd be able to get all the right answers. I want to call you Jacqueline, but that's your sister.
Yeah.
Maddie? Maddie.
Yeah.
Okay. I was just, I don't know. It's been a long day
I'm sorry.
already, and it's 9:20.
Okay, so after you said subtract b and then you use the absolute value, but you didn't use the absolute value like.
When I typed into my calculator,
Yeah, it was just.
I just did it in my head.
Oh.
Right? The absolute value of 0.19 is just 0.19.
Oh, okay.
Right? Because the absolute value just makes something positive.
Okay.
So rather than wasting like all the buttons on my calculator to get the absolute value, I just do it in my head.
You only have to do it if it's negative.
Well, I mean, you're still doing it. It just gives you the same number.
Okay.
Right?
All right.
I mean, like I'm still doing it. I just don't have to do anything to do it.
Okay.
Or nothing changes when I do it.
All right.
Is that
Yeah.
okay? Yeah, so important point. I am doing it even if what I'm doing does nothing. Right? I'm still taking a moment and going, okay, I'm doing the absolute value. What changed? Nothing. Okay, moving on. Oh.
You know, I'm saying like.
Oh.
It's a dosage question. What's up? Anybody else? You want to do some more? It's fair warning, this is going to be the last day we spend in chapter 4 before we do the review and the test. Does that change anybody's tune about where they have more questions?
So it's just like 2 less than.
Let's do another.
Okay, great.
Homework with
I mean, yeah, but is it going to be today?
No.
No. So what's that mean? It's got to be next time.
Wait, then when's our next week?
The class after that?
Eventually.
I know.
Not 20.
Tuesday. No, Monday. Wait, no, Tuesday. No. Yes.
We'll meet again on Friday. We'll do the review and the homework quiz. And then take the test the next class, which would be Tuesday, I think.
Are you just gonna give us like problems to do for the virtual day?
Next week. Thursday and Friday.
I might give you like a delta math or something to do. That feels like a good use of a good day rather than trying to start something new if we just took the test. What do you guys say? Fair enough?
Yeah.
Feels better than trying to like figure something new out on your own. Okay, Maddie, you said you wanted to do another one?
Yeah, anyone really, like anyone you think it's important to know for the homework. Yeah.
I mean, the homework quiz is going to be like worksheets 1 and 2.
Okay.
So like those are the kinds of problems you're going to get. There's just stuff like that.
Is this a question? This is a question from worksheet 2.
Yes,
Can we do any questions from worksheet 1?
sure. Does anybody have a preference, since it sounds like Olivia doesn't? Number 2. Okay. Sure thing. There's no bad ones. All right. So cosine here is positive, right? The same, and cosine is the same as x. What quadrant is x positive in? 1 and 4. Draw the picture if you need to. Yeah. It's hard to screw it up if you draw the picture. You know what I'm saying? Okay, let's look at the quadrants covered by pi to 2 pi. So starting from the positive x-axis and rotating counterclockwise, half, 1, 1.5, 2. So that covered quadrants 3 and 4. Where's my answer going to be? Quadrant 4. Everybody's cool?
Yeah.
To get this answer, what do? I go to the unit circle. I look in quadrant 4 for the place where the x coordinate is square root 2 over 2. That happens right there. So my answer would be 7 pi over 4. And I'm done. Again, this is completely checkable. We can check it the same way we did the previous ones. So if I do cosine of 7 pi divided by 4, I better get the square root of 2 over 2. Wait a minute, I got this kooky decimal. Well, that could be the square root of 2 over 2. Let's see what the square root of 2 over 2 looks like. Notice that when I type this into the calculator, the square root bar only is over the first 2. It doesn't extend over the whole thing. Oh, good. It's the same number. So the first part of my check works. The second part, I have to make sure that 7 pi over 4 is between pi and 2 pi. Well, I can do that without even the calculator, right? 7/4 is 1 3/4. Everybody agree? So that's 1 3/4 pi. That is definitely between 1 pi and 2 pi. So I'm satisfied. That's got to be correct. Maddie, are you tappy there?
Yeah.
Very similar, right? The process. The only difference is once I figure out where what quadrant it lies in, here I just go to the unit circle and look it up.
Okay. Yeah.
And the other one I have to like draw the picture and write my equation, type the stuff into my calculator. So it's a little bit more on the second one, or this on the worksheet 2 problems, but the start of both of them is identical. right? We got to figure out where our answer is. And that's nice, at least, right? That they all start the same way. You guys want to do more of these, or do you want to finish up?
Can we do the first one? We can.
Sure. It's on this same page. So tangent on the unit circle is y over x. Now, if I divide two numbers and I get a negative, what does that say about the two numbers I'm dividing? One of them has to be negative. So we're either looking for where x is negative and y is positive, or where x is positive and y is negative. Everybody agree with that? So x is negative and y is positive, that's quadrant 2. And x is positive, but y is negative is in quadrant 4. Everybody's okay with that? Again, if you get hung up on that, like, you know, like draw in on your note card that picture that identifies like what coordinates are positive and negative in which quadrant, right? If you get hung up on it, you know, this is like Q1, Q2, Q3, Q4. Everybody's okay with that picture?
Yeah.
So again, if you get hung up on that, or if you make that mistake, have a picture on there that you can go and look at and be like, okay, which quadrants is the x positive in? You know, oh, 1 and 4. Or which quadrant is, you know, x negative but y positive? Oh, that's quadrant 2. You know what I mean? Like, you get a lot of stuff. You can put anything you want on there. You got a whole front and back of a half sheet of paper. Most of us don't fill that thing up. You know what I mean? I'm just kind of pointing out stuff that you could put on there that would be potentially helpful. You know what I mean?
Yeah.
And rather than just waiting till last day, I'm trying to point it out as we go. Emma? Sure. Okay. Let's finish this up now. So here, what quadrants are covered by the angles from pi to 2 pi? I don't even need to draw the picture. I know it's Q3 and Q4. How did I know that? I mean, it was the same as this one was, wasn't it? We just did it. So I'm not going to draw it again. We just did it, right? Like, oh, I already did it. Ha ha ha. So where's my answer? Q4. So tangent's a little bit tricky now on what I'm looking for on the unit circle. So if I take my equation, y over x has to equal -1. If I multiply both sides by x, I get that y has to be the negative of x. Everybody's okay with that? So I'm just going to look for two things in quadrant 4, the x and y coordinate, that are just opposite numbers. Right? So that one part has to be the same, but the other part has to just be the same thing with the opposite sign. Okay? So we're just looking for two opposite numbers. So I go to my unit circle, looking in quadrant 4. Look at this. X is positive root 2 over 2. Y is negative root 2 over 2. Those are the same numbers, just with opposite signs. That's the spot I want. It is the same answer as last one, which is 7 pi over 4. That is exactly what we got. And again, you could check that. You check it the same way we just did. I'm not going to go through the check again if that's okay with you guys. You know, the checks all feel the same. I've reinforced it a lot, I feel like. Okay. All right, what do you guys think? Oops, I didn't want to do that. I just wanted to scroll down a little bit. All right. All right, 4.1 part 3. Here in this section, or the last piece that we need to do in this section, we're going to need to remember the ranges. So for sine inverse, the range was negative pi over 2 to positive pi over 2. For cosine inverse, the range is 0 to pi. And for tangent inverse, the range is pi over 2 to, or negative pi over 2 to positive pi over 2. Those would be good things to put on your equation sheet or your note card or whatever you want to call it. And I'll show you again how we're going to use these in just a moment.
Is that pi over 2 or pi over 3 for the side?
They're all 2's. Oops. Let's do this. All right. So let's say we ask you to find the exact value of cosine inverse of tangent of 45. So this looks complicated, but it's not really a big deal. So the trick here on one of these problems is we want to start from the inside and work our way out. So the first thing we're going to look for is tangent of 45. How do I do tangent of 45? Well, if I want an exact value, I probably don't want to go to my calculator. I go to my unit circle. Great, let's paste one of those in here. So I found 45. And what is tangent? Y over x. So what's root 2 over 2 divided by root 2 over 2? Exactly, yeah. If you take a number and divide it by itself, doesn't matter how goofy that number looks, it's still just 1. Everybody's okay with that?
Yeah.
Now, we're going to just go for cosine inverse of 1. But what do I need to remember on this? Yeah. So that angle that I'm solving for cosine inverse needs to be between 0 and pi. Everybody's okay with that? Okay. So cosine inverse of 1 is the same thing as looking for cosine theta of 1. So the x is positive in quadrant 1 and quadrant 4. Here, the angles from 0 to pi are covered by quadrants 1 and quadrants 2. Where am I looking then? In just quadrant 1. So I'm going to go to my unit circle. And just look in quadrant 1 for where x is equal to 1. Oh, there it is. So what's my answer then? 0 degrees. And I'm done. Everybody feel okay doing that? Not too big of a deal, right? It just, same thing we've been doing, we just added on an additional step where you have to figure out like what was inside. All right, do another example. Okay, where do we start? The inside. So we're going to go to the unit circle and find y over x when our angle is 2 pi over 3. Everybody's cool with that? Why are we looking for y over x? Because it's tangent. Okay, so we'll go over here to my unit circle. I've located 2 pi over 3. So y over x is going to be root 3 over 2 divided by negative 1/2. Everybody's okay with that? But now, if I'm doing the arctan is really the same as tan inverse, right? So if I'm using that, I need to make sure I'm using my range for tan inverse. So that's not 0. Everybody's cool? Okay. What quadrants are covered by the angles from negative pi over 2 to positive pi over 2? So starting at 0 or on the positive x-axis, if I'm going down to negative pi over 2, I'm going clockwise because it's negative. So that's like negative pi over 2. Oh boy. And then again, starting on the positive x-axis to get to positive pi over 2, I'm going counterclockwise. So we covered quadrants 1 and 4. Everybody cool with that? I notice up here that this would be the same thing as saying tangent of theta should be negative. I don't even want to bother copying the whole number. All I really care about is that it's positive or negative, right? So from quadrants 1 and 4, which one can tangent be negative in? Quadrant 4, right? Could also be quadrant 2 also, but we don't care about that. Quadrant 4 is what we need. Everybody's cool with that? Okay. So using this, I'm going to go to the unit circle, and I'm going to look in quadrant 4, where the y-coordinate has a square root 3 over 2 in it, and the x-coordinate has a 1/2 in it. Now, which one should be negative if we're in quadrant 4, the x or the y? The y. Everybody's cool? Okay, so let's go to quadrant 4 and find that. My x is 1/2, and my y is negative root 3 over 2. So I have 5 pi over 3. Unfortunately, that's not the correct answer. What's wrong with that? It's too big. Remember that I have to be between negative pi over 2 and positive pi over 2. That's too big. Oh no! What do I do? Yeah, I'll just subtract 2 pi. Great. So subtracting 2 pi when I make a common denominator, same thing as 6 pi over 3. So 5 over 3 minus 6 over 3 is negative 1 over 3, or in this case, negative pi over 3. And we're done. Again, I wrote down a bunch of stuff because I'm trying to show my work. These are notes. Conceivably, this is not something that would take this much writing down, but I'm trying to justify to you, if you're going back and looking at this, why am I doing the next thing that I'm doing? You know what I mean? So it's kind of I don't know, it's a little all over the place, messy, but you'll just have to deal with it. Does that feel okay? That's the last section 4.1 skill that we wanted to do. We do want to talk about section 4.2 still. So I want to start with a little bit of vocab. There's two terms here that are going to be important. The first is angle of elevation. I often will abbreviate that AOE, angle of elevation. And the other is angle of depression. That would be AOD. Everybody okay with that? So to define what I mean by these things, I'm just going to draw a little bit of a picture. So I have two people, right? One person's on the ground, one person's on the top of a building or something. If I'm the person at the ground, I'm looking straight ahead. This would be like my line of sight. Everybody agree with that? If I then lift my head to look up at that person on the top of the building, that angle that I formed here is an angle of elevation. Why is it elevation? Because I'm lifting my head up to look at them. Everybody agree with that? Sure thing. Okay. Same picture. So this time, let's pretend we're the person up at the top of the building. If I'm just looking straight ahead, that would be my line of sight. And say I want to look at that person on the ground. I'm going to put my head down to look at them. This angle here that's formed is the angle of depression. I'm going to say this now. Because probably 2/3 or maybe more of us are going to consistently get the angle of depression wrong. Your instinct is going to be you're going to want to put the angle of depression there. It does not go there. It does not go between the vertical and the person. It's between the person's line of sight and what they're now looking at. Okay? We'll do an example. We have some example problems here coming up in which we're going to see that specifically. But I wanted to prep you on that, is that there is a big difference between those two locations. And it is a really common mistake, particularly in this class. Oops. So let's do some examples now. So my first example says, Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? I'm going to start by drawing a picture here. So there's Christy. There's the top of the Fisher building. Now, where am I going to put the 200? It says she's standing 200 feet from the base of the building. On the bottom here, right? Let's give this point a name. I'll just call it X or something. And it says the angle of elevation to the top of the spire is 66 degrees. So what angle would we be talking about there? Yeah, which is FKX, which is 66 degrees. And what we're looking for then is the height. Now there's one other piece of information that we can assume here. What other piece of information can we assume that's actually going to be very necessary to do this problem? So this is a right triangle. Why can I assume this is a right triangle? Buildings sit perpendicular to the ground, right? It's a poor building design if it's like tilting one way or the other. Yeah, talk to the Italians on how that works out. It was not intentional. They built on a bad foundation. The ground sunk. It's actually a marvel that the building hasn't fallen over. Okay. Everybody feel good about the picture we've drawn here? How I got the picture from the words? All right. So I need to solve for H. What am I going to use to do that? I have a right triangle. SOHCAHTOA seems like a natural fit here. Sine, cosine, or tangent, which one of those would be the one to use? So relative to this angle that we know, what is the 200? That is adjacent. And what is the H, the side we want to know? Opposite. So we should use tangent. So we'll say tangent of 66 degrees equals opposite over adjacent. Does everybody feel okay with how I came up with that? Okay. To solve for H, what do I need to do? I need to solve this equation for H. How do I get the H by itself? Multiply both sides by 200. Yes. So those will cancel out. And I'm left with 200 times tan 66 is equal to H. Now it's calculator time. What do I have to be careful about here? The mode. What mode should my calculator be in? Degrees. This is going to be important on the test because you're going to have to be switching back and forth on your calculator modes. So get used to it. So 200 times tan 66 gives me 449.2. I have no idea if that's actually accurate. But it's probably reasonable. Fisher Building's probably 40 stories tall or so. That doesn't seem out of line. Not like it's the Empire State Building or anything. Any questions on what we've done there? Reasonably straightforward, right? Hardest part is probably getting the picture correct. And once you've done that, it's kind of a geometry problem, right? Something that you would have done in geometry anyways. Let's do another. All right. Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet in the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? So I'll start by drawing myself a picture. So there's Jane up in the tree. There's Mary down on the ground. Says Jane has climbed 17 feet into the air. Where does that 17 feet go in our picture? JX, right? Okay. And it says the angle of depression to Mary is 49 degrees. So I don't know, what do? I do this, right? No! This is what I warned you about. Isn't it tempting to want to do that? Where does the 49 need to go? It needs to go there. Everybody's cool with that? And what are we looking for then? How far is Mary from the base of the tree? So what is that? XM, right? So I'll call that D for distance or something. I don't know. Everybody cool with what we're doing? So we have two options here. Well, there's one other assumption that we can make here. It's a right angle because trees usually grow straight up and down. Okay. So two options here. One is we can use this triangle here. Where this side would also be 17 and this side would be D. Everybody's cool with that? I've just made it like a rectangle. Or what's the other option? Is we can use this triangle, but we're going to need to find an angle in it. What's this angle got to be? It's got to be the complement to 49. Or, in the green triangle, what does this angle have to be? 49. Why does it have to be 49? We have a name for this situation. Back to geometry. Those guys are alternate interior angles. And we know that alternate interior angles are congruent. So it doesn't matter whether you think about this as the red triangle or the green triangle. You'll get the same answer either way. But I just wanted to point out to you that there's kind of a lot of ways to set this up. All right. Let's just say, for the sake of argument, we're using the red triangle. Since it's a right triangle, we're going to be using SOHCAHTOA. Which angle do we want to use? 49. Relative to 49, what is this or what is side D? Opposite, adjacent, or hypotenuse? Okay, that's adjacent. And then the other side, we know the 17, that is opposite. So we should be using tangent. So far, so good? If I want to solve for D, what should I do next? If I want to solve for D, what should I do next? Multiply D to both sides. Sounds like a great first step. That's going to get rid of the fractions for me. And typically that makes our life easier. Okay, now what? Divide by tan 49. What's the other color? Again, mode should be in degrees because the angles are in degrees. So I do that, I get 1478. What do you guys think? That's the gist of it. So for next time, what would I like you guys to do for me? 11 to 14, and then 19 to 22, and worksheet 3. And this will all be also due on the 6th. Actually, what else is due on? Is everything due on the 6th so far in chapter 4? Okay, we'll just make that the 13th then or whatever. Right? That's fine. It's not like you're not going to do it before then anyways, because the test is next week, but no need to rush to get it into OneNote or whatever. Okay. Everybody feel good? Or good enough?